The eagle has landed. Welcome to maths. This is the Mangeya, the maths eagle. Right. So this part is for Cambridge International Advanced Level Mathematics. It's pure mathematics paper 3 for May, June 2021. Variant 1. Then after watching this video, please like, share and subscribe to this nice powerful item. Let's start the ball rolling. Instructions. Non-exact values, they must be given to 3 significant figures unless or otherwise stated. Then angles in degrees, they must be given correct to 1 decimal place. Please take note, it's angles in degrees, not in radians. Question number 1. Solve the inequality. So these ones are called modulus inequalities, right? So what you do is you just square everything. Like on the left side of our inequality sign, we have 2. You square 2, you square 3x minus 1, you also square x plus 1. So it's to get rid of the modulus function. So let's do the working. It will be 2 squared, then you put 3x minus 1 inside the bracket, then you square it, less than x plus 1 squared, like this. After that, you then have to expand. This side 2 squared, it means it's 4. Then this bracket 3x minus 1 squared means 2 brackets of the same, which means 3x minus 1, 3x minus 1 less than, then this bracket twice x plus 1, x plus 1. Now let's expand the left and expand the right side of our inequality sign. We can maintain our 4 outside the bracket. Then it will be 3x. The values in the first bracket multiply the second bracket. So you have 3x in the first bracket and minus 1. 3x to multiply 3x minus 1, and minus 1 multiplies 3x minus 1. Close our bracket, then less than. Then in this bracket we have x, in this and plus 1. So x will multiply the second bracket, which is x plus 1. And plus 1 will also multiply the same bracket, which is x plus 1. Let's simplify our brackets. It will be 3x times 3x is 9x squared. Then 3x times minus 1, minus 3x. Then minus 3x here. Minus 1 times minus 1 is plus 1. Less than. Then x times x is x squared plus x. Then 1 times x is plus x. Then plus 1. Then let's simplify further. You get 9x squared. Then minus 6x plus 1 less than x squared plus 2x plus 1, like this. Now let's remove the bracket on the left side of our inequality sign. 4 times 9x squared is 36x squared minus 24x, then plus 4 less than x squared plus 2x plus 1. Now let's collect like terms. Like terms, you can say 36x squared. Take everything to the left side of our inequality sign. So it will be minus x squared. Then minus 24x minus 2x plus 4 minus 1 less than 0. Then subtract, you get 35x squared. This part you get minus 26x, then plus 3 less than 0. After that, you have to find now the critical values of x. What are the critical values in this case? You can either use the quadratic formula, you can use completing the square method, or factorization. I can prefer to use the quadratic formula in this case, right? So using the quadratic formula, it will be a is 35, then b is negative 26, and c is equals to 3. Then the quadratic formula says what? It says x is equals to minus b plus or minus square root of b squared minus 4ac, 4 times a times c, all over 2a. That is 2 times a. Right, let me use this formula. I can say my x here is equals to negative b with negative 26. That's b, plus or minus square root of b squared, which is minus 26 squared minus 4ac. What is my a? Is 35. Then my c is 3. All over 2a, which is 2 times 35. Right, let's simplify this part. What do we get? Let me find my calculator here. Then 3. Right, the first value of x that you can get after punching everything in your calculator, it will be x is equals to 3 over 5, or x is equals to 1 over 7. So these are the two critical values of x. Now you can draw your quadratic graph. It's like this. Then you put the smaller value here, which is 1 over 7, and the bigger one, which is 3 over 5 here. Then you check on your inequality sign. You can check this one. It's here. It's less than. Less than, it means we need the area that is below the line. This is the area between the line, bounded by the line and the curve. This is the area that we are looking for. So if you can check the area, it will be x between 1 over 7 and 3 over 5. So this will be the solution set. Done. Question number 2. Find the real root of the equation. Real root of the equation, giving your answer correct to 3 decimal places. Your working should show clearly that the equation is only one real root. So in this case, they're saying one real root. So these equations, basically, the working is the same. They will always lead you to quadratic, right? But as you can see, this one is an equation with fractions. How do you work out this part? You have to remove the denominator first. So deal with the denominator. You can use cross multiplication, or you can use the lowest common multiple method, whichever method you can use. I can use cross multiplication in this case. So it means 2 plus ex is supposed to multiply 3. So it will be 2ex plus e minus x. Then 3 multiply 2 plus ex, or e to the power x, like this. Right, let me remove the bracket on the right side of our equal sign. It will be 2 e to the power x plus e to the power negative x. Then 3 times 2, 6. 3 times e, it will be 3 e to the power x, like this. Right, these equations basically, you can say let y is equals to e to the power x, like this. So that's how you're supposed to deal with equations of this type. Some of them, they'll be having square roots. It's just the same group of equations. Right, you can say now, before I can put my y, let me apply the laws of indices first. E to the power x, that is any number, x to the power minus a, raised to the negative power, is the same as 1 over the same number, which is x, when raised to a positive power. So this is the law that you have to apply in this case on e to the power negative x. So the same as 1 over e to the power x, positive power. Then is 6 plus 3 e to the power x. Right now I can substitute. I can put a y instead of e to the power x. So it will be 2y plus 1 over y is equals to 6 plus 3y, like this. Then I can now get rid of y, that is my denominator. I can use the lowest common multiple method. I multiply everything by the lowest common multiple of the denominators. In this case, it's y. So I can multiply everything by y. 2y by y is 2y squared. Then 1 over y times y is plus 1 is equals to 6 times y is 6y plus 3y times y is 3y squared, like this. Then I can take everything to the left side of my equal sign. It will be 2y squared minus 3y squared, then minus 6y plus 1 is equal to 0. I'm expressing as a quadratic equation. Here you get negative y squared minus 6y, then plus 1 is equal to 0, like this. I have to make sure that the coefficient of y squared, or the one with the squared, must always be positive. So how can I do that? I can multiply everything here by minus 1. Minus 1 times So it will be y squared plus 6y minus 1 is equals to 0. Then after that, I can now use the quadratic formula to simplify or to solve this item, right? So using the quadratic formula, I can say my a is equals to 1, my b is equals to 6, my c is equals to negative 1. Then I can say y is equals to minus b, which is minus 6 plus or minus square root of b squared, that is c squared, minus 4a, which is 1, c negative 1, all over 2a, which is 2 times 1. Then it will be minus 6 plus or minus then root of, then inside the bracket, the square root actually, this minus and this minus, it will make a plus. So it will be 6 squared, which is 36, plus 4, which is 40. So it will be root of 40 over 2 times 1 is 2. Then if I can make use of my calculator, the one of the solutions is with a minus 6 minus, and the other solution minus 6 plus, root of 40 over 2. Right, I can say here, then right, the first solution is x is equals to minus 3 plus root 10, and the other solution minus 3 minus root 10. This one is y actually. So y is equals to minus 3 plus root 10, or y is equals to minus 3 minus root 10, like this. Right. What you want here, what you are looking for is x, not y. And we have let our x to be, our y to be e to the power x. So you can take these two items. You can say e to the power x is equals to negative 3 plus root 10, or e to the power x is equals to minus 3 minus root 10, like this. Right, to get rid of e to the power x or e, you put ln, introduce ln both sides, You can also say ln here, and you can put ln on this side, ln or ln, some ln, whichever way. I prefer calling it ln. So it's ln e to the power x is equals to ln, then minus 3 plus root 10. Right, the other thing that you take note of, there is no ln of a negative number. It's undefined actually. Like you can see this one, if you can simplify this part, you get negative. So which means this solution, we can say no solution on this part. No solution. Then on this part, let's try to check if we can say minus 3. If I can say minus 3 plus root 10. Well, the solution is positive. It's positive. So this one is correct. So I can take this one and find a solution based on this part. So ln e to the power any number is equal to that number, which means ln e to the power x is equals to x is equals to ln, then I can get 0.16227766602, something like this. Then I can say ln of answer, then I'll get negative. So x is equals to negative 1.81. How many decimal places or significant figures? In this case, they said 3 decimal places, right? So this will be the solution to 3dp. Please take note. Ln e to the power n number x is equals to x. Also, e to the power ln x, then it's equals to x. So these are the two critical solutions that you have to understand, to know actually, when it comes to logarithmic functions. Right, question number 3. Given that cos x minus 30 equals to 2 sine x plus 30, show that tan x is called this one. Right, tan x identity is there in a formula booklet, is sine x over cos x. That's tan x. So we have to make sure that my denominator is reduced to cos x and my numerator is supposed to be reduced to sine. Right? So that's sine over cos, so that I can be able to get my tan. Right? Then there are expansions that you have to know. We have for cos and for sine. Cos a plus b. In this case, it's minus b. Cos a minus b is equals to So it's cos A cos B plus sin A sin B. Is there in a formula booklet? Then I can say also for sin A plus B goes sin plus 30. Sin A plus B is equals to sin A cos B, then plus cos A sin B. That's for sin, right? Then I can, let me apply these items in the expansion of these things, of cos and sin. So on cos here, I can say cos x, then cos 30, plus sin x, sin 30, equals to, then to be true, I can expand sin first. It will be sin x cos 30, then plus cos x sin 30, like this. Right, what is cos 30? Cos 30 from the calculator or from the triangle is root 3 over 2. Say cos 30, root 3 over 2. So it will be root 3 over 2 cos x plus sin 30 is half. Half sin x is equals to 2. Then cos 30, that's root 3 over 2 sin x plus sin 30 is half cos x. Then you can remove the bracket on the right side of the equal sign. You get root 3 over 2 cos x plus half sin x equals to, then this will be root 3 sin x, then plus cos x. Then what do I have to show in this case? Is 2 minus root 3 and 1 minus 2 root 3. So it's minus 2 root 3, which means the items with the root 3, they must be subtracted, right? So in this case, I can move sign to the left or the sign, to the right side of the cosine, or I can choose to do the same with cos. So, but in this case, for it to be minus root, it means I have to take cos to the right side and sine to the left side, such that it will be half sin x minus root 3 sin x is equals to cos x minus root 3 over 2, then cos x, like this. Right? Then I can factor out sin x on the left side. It will be sin x, then half minus root 3. Then on the right side, I can also factor out cos x. I'll be left with 1 minus root 3 over 2, like this, yes. Then I can divide by cos everywhere, so that I will get my tan. This will be sine over cos. That will be tan. So I can divide by cos x, like this. And I'll get tan here. So it will be tan x, then half minus root 3 equals to, then this side cos will cancel out. I'll be left with 1 minus root 3 over 2. Then I can divide by half minus root 3, so that I'll get tan x is equals to 1 minus root 3 over 2 over half minus root 3. Then after that, I have to express the numerator under one denominator and the denominator also under one denominator. So I will say, in this case, this one is 1 over 1. This down or root 3 is 3 over 1, like this, right? So let me explain the numerator under one denominator. So denominator of the numerator is 2. Then I say 1 into 2 is 2 times 1 is 2, minus 2 into 2 is actually 1 times root 3 is root 3. Then over, then I can say here, 2 into denominator is 2 down there. Then I can say 2 into 2 is 1 times 1 is 1, minus 1 into 2 is 2 times root 3 is 2 root 3. Then this 2 and this 2, they'll cancel out, so that I will be left with tan x is equals to 2 minus root 3 over 1 minus 2 root 3. All right, let me check. Is it the one that we're supposed to find? Yes, that's correct. So 2 minus root 3 over 1 minus 2 root 3. So in this case, shown. Done. Then part B, yes, solve the equation for x between 0 and 360. Right, you can check this equation is the same as the one that I found up there. It's still the same thing. So I can just pick that item. I can say tan x equals to 2 minus root 3 over 1 minus 2 root 3. Right. I prefer to use the quadrant rule to solve these trig equations, right? You can use the formulas, yes, they work, but I would prefer to use the quadrant rule. So for me to be able to use the quadrant rule, I must check this 2 minus root 3 over 1 minus 2 root 3, is it negative or is it positive? So that I can know which quadrant that is my solutions line. So I can punch in my calculator 2 minus root 3 over 1 minus 2 root 3. Then I will get negative 0.10874 like this. Yes. So it's negative. So I can see that tan x is negative, which means my solutions, if I am to find them, tan is negative in which quadrant? Actually in the second and the fourth quadrant. In the second and the fourth quadrant, second and fourth, which means my solutions are supposed to be here, then second and fourth quadrant. So I have to find my PV, my principal or primary value. So my PV, I will say x is equals to arctan of, then you don't have to put the negative when punching in your calculator. The negative will be on the quadrant, right? Which quadrant is your solution lying? So it will be 0.10874, right? If you can punch this one in your calculator, let's say arctan, second function arctan, 6.21. 6.206, so it's 6.21 degrees. So this one would be my PV, principal value. That's the one that you have to put here. 6.21, 6.21. Right, my solutions now, they are always from the positive x-axis. It's on the positive x-axis. From this one to the first line, it's 180 minus, so it's x is equals to 180 minus 6.21. That's my angle there. 180 minus 6.21, then I get 173.8. To 1 decimal places for angles in degrees, please. Then the second solution is from 0 to 360. It's from the positive x-axis to the second line, which is 360 minus 6.21. 360 minus 6.21. What do we get here? 360 minus 6.21. Which is 353.8 degrees. So these are the two solutions or values of x between 0 and 360. Then question number 4, prove that this one is an identity. So you always have to check the sides with many values, right? As I can see in this case, is the left side of the identity or in identity sign, right? So I can take the left side, so I can say taking left hand side. Right. I have cos 2 theta in this case. Right. Tan squared is what? Is sine squared theta over cos squared theta. That's tan squared. Which means I have to deal with my numerator so that it will be reduced to sine squared. And my denominator so that it will be reduced to cos squared theta. That's what I have to do. But I have identities in this case. For cos 2 theta, we have an identity in terms of sine theta and in terms of cos theta. Right. So cos 2 theta is equals to 1 minus 2 sine squared theta. In your formula booklet, you can find this one. Then cos 2 theta in terms of cos theta, it will be 2 cos squared theta minus 1. So these are the two identities that I have to apply in this case, right? So I can say here, on the numerator, it will be 1 minus, then where there is cos 2 theta, it's supposed to be sine. So it's 1 minus 2 sine squared theta over, then 1 plus then this will be 2 cos squared theta minus 1. Let me remove the brackets, numerator and denominator. It will be 1 minus 1 plus 2 sine squared theta over 1 plus 2 cos squared theta minus 1. While the numerator, 1 minus 1, 0. It will be 2 sine squared theta over denominator, 1 minus 1, 0 over 2 cos squared theta, like this. Then 2 and 2 cancel out. This 2 and this 2 cancel out. We'll be left with sine squared over cos squared, which is the same as tan squared theta. Shown. So it's identical to tan squared theta. Done. Right. Part B. Let's find the exact value of this item. Right. I just have to take tan squared in this case, because it's identical to this item. So instead of using this expression, I can just use tan squared. So it will be integral of tan squared theta, then d theta, then it will be pi over 3, then pi over 6. That's 1 over 6 pi. It's the same as pi over 6. Right, this is the item that I have to integrate in this case now. But tan squared can't be integrated. It can only be differentiated. So in this case, I have to use the identity for tan squared. What is the identity? Is there in your formula booklet? Is tan squared theta plus 1 is equal to sec squared theta. So it will be tan squared theta is sec squared theta minus 1. So this is the identity that I have to apply in this case. So what can be integrated is sec squared. So I can use sec squared in this case. Sec squared theta minus 1. Then d theta. Then the limits is pi over 3 and pi over 6. Right. Integrating sec squared, you get tan. So it will be tan theta minus integrating 1, you get theta. Then I can put my limits pi over 3, then pi over 6. Right, substitute now. It will be, I can put pi over 3 first. So it will be tan pi over 3 minus pi over 3. Then minus, I can now put pi over 6. It will be tan pi over 6 minus pi over 6. Then I can simplify. What is tan pi over 3? If your calculator is in degrees, then your pi over 3 is 60 degrees. So you can say tan 60. If you can prefer to work with degrees, then you get root 3 minus pi over 3. Then minus tan pi over 6. Pi over 6 is what? Is 30. Is 30 in degrees. So tan 30, what do you get? You get root 3 over 3. Then minus pi over 6. Let me remove the bracket. Minus pi over 3. Then minus root 3 over 3. Then plus pi over 6. Then collect like terms. In this case, I have root 3 minus root 3 over 3. Then I can say plus pi over 6. Then minus pi over 3. Right, on this part, I can say this will be over 1. 3 root 3 minus root 3, it will be 2 over 3 root 3. Then on this part, it will be times 2 over 6. So it will be pi over 6 minus pi over 3, 1 over 6 minus 1 over 3. So 6 here, 1, pi, 2, so it will be minus pi. Like this. Then done. Right. Next item. Am I supposed to find the exact? Yes, it's the exact value of. You can choose to put this one under one denominator. Still, it works, right? So it will be over 6. It will be 3 into 6 true. So it will be 4 root 3 minus pi. It's still the same thing. Right. Then question number 5. These are complex numbers. Solve the equation z squared or z squared minus 2piz minus q is equal to 0, where p and q are real constants. These are real numbers. Right. This one is a quadratic equation in z. Right. So what I'm supposed to do You can use the quadratic formula, or you can use completing the square method. Those are the methods that you can apply in this case. So let me use the quadratic formula. It's a bit more straightforward. So I can say a is equals to 1, the coefficient of z squared. Then b is equals to minus 2pi. Then my c is equals to negative q. Then from this one I can say my z, in this case it will be equals to minus b, which is minus 2pi. Then plus or minus square root of b squared minus 2pi squared minus 4ac. A is 1, c is negative q, all over 2 times a, which is 2 times 1. So it will be minus 2pi is positive. So it will be 2pi plus or minus root of minus 2pi squared. You say 2 squared is 4, p squared is p squared, I squared, I is I squared, then minus and minus, it will make a plus here, then 4q, all over 2 times 1 is 2. Right, let me simplify using I squared is equals minus 1. Right, I can simplify inside this under the square root. It will be 2pi plus or minus root of, this will be negative 4p squared plus 4q, all over 2, like this. Then this item can be simplified further. If I can check here, it is the same as 2pi plus or minus, then is root of, let me start with the positive, 2q minus 4p squared all over 2. Then this the same as 2pi plus or minus root of, I can factor out 4 here, then I'll be left with q minus p squared over 2. Right, take note, root of a times b is the same as root of a times root of b. So this is the thing that I have to apply now. So root of this part the same as root of 4 times root of q minus p squared. So it will be 2pi plus or minus root of 4 times root of q minus p squared, all over 2. While simplifying further, it will be 2pi plus or minus 2 times root of q minus p squared, all over 2. I can factor out 2 on the numerator. It will be 2, then pi plus or minus root of q minus p squared, all over 2. Then these 2 and these 2, they will cancel out. 2 cancel out. Then the final answer will be pi plus or minus root of q minus p squared, like this. Then the 2 down here has been cancelled, so there's no 2 down. So these are your solutions. So it will be pi minus root of q minus p squared, or z is equals to pi plus root of q minus p squared. So these are the solutions for our z. Right, second part B. In an Argand diagram with origin O, the roots of this equation are represented by the distinct points A and B. Given that A and B lie on the imaginary axis, find the relationship between P and Q. So on an Argand diagram, so the Argand with imaginary x here, imaginary y, then real x. So they're saying these roots, there are 2 distinct points A and B. Given that A and B lie on the imaginary axis, find a relationship between P and Q. So it means my roots, this and this, that I found, then they must be imaginary, right? So for them to be imaginary, then I must be able, in this case, I must get a negative number under the square root, right? So it means q minus p squared must be a number that is less than 0, that is negative, so that I will find the square root of a negative number, then I will put I for minus 1, I squared for minus 1. Then my solutions will all be imaginary, right? So in this case, the thing under the square root, which is q minus p squared here, must be less than 0. So I can say q minus p squared must be less than 0. So in this case, I can say q must be less than p squared. Right, taking this one to this side, So this one, the solution relation between P and Q. So Q must be less than P squared, so that the solution to this item are supposed to be all imaginary. Right, part C, given instead that triangle OAB is equilateral, then express Q in terms of P. Right, equilateral triangle, if I can have my triangle here, let's say OAB, let's say this one is A, this one is B, something like that. So if this one is equilateral, then there are two things there. We have the first item based on the argument of a complex number. The angle here inside must be 60 degrees or pi over 3. This angle 60, 60, 60, 60. Then the other item, so the argument of I can say OA must be equal to, argument of OA must be equal to 60 degrees, which is pi over 3. Or I can say OA, this one's OA is equals to OB. So the modulus of OA must be equal to the modulus of OB. Right? So these are the two items that I'm supposed to use. So I can choose to use the first part, that is of the argument, right? So argument of OA then must give you this item. Then I can check my OA is this one. I can say PI plus, this one is OA, PI plus root of Q minus P squared. So I can say OA is equals to PI plus root of Q minus P squared. Right. So from this, you can check. My imaginary is P. My real is root of Q minus P squared. That's my real part, right? So this, the argument of a value of a number, actual of a complex number is arctan of. You can say tan y over x. So this one is x. This one represent x. This one represent y. So you can say argument, you say tan theta is y over x. That's argument, right? Of a complex number. So I can use the same item. So tan theta, in this case, my theta is what? Is pi over 6. That's my angle, right? So I can say in this case, tan, or I can say, let me start with y over x. Y is p over x, which is root of q minus p squared, is equals to tan of pi over 6, or 60, pi over 3. Pi over 3 is 3, that's 60 degrees, not 6. Take note of that part. It's pi over 3, not pi over 6. That's 60 degrees. Right, so this item, that's that I have. So I have to express my Q in terms of P. Right. I can simplify. What is tan of 60? Tan 60, if it's in degrees, is root 3. Radians is pi over 6. Use pi over 3. So it's root 3. So it will be P over Q minus P squared is equals to root 3. Right. I just have to simplify because I have to express this Q in terms of P. Q is equal to something with P. Right, it will be P, or I can just, to remove the square root, I can just square everything. So it will be P squared over root of A minus P squared, then squared, is equals to root 3, then squared. Yes, so I can just square everything in this case. So it will be P squared over A minus Q minus P. This one is Q. You see the effect of point writing. So it's just supposed to be is Q. Now I was seeing it as A. Oh, serious one. Then is equals to root 3 squared. Root 3 times root 3 is 3. Right, then I have to cross multiply. This will be over 1. It will be P squared is equals to 3. Then Q minus P squared. Then P squared is equals to 3Q minus 3P squared. Right, collect to the right side, left side is P squared plus 3P squared is equals to 3Q. Then to be 4P squared is 3Q. Then divide by 3 because you want Q in terms of P. Divide by 3 by 3. What do you get here? You get 4 over 3P squared is equals to Q. So Q is equals to 4 over 3 P squared. So this will be your solution. Done. Right, question number 6. The parametric equations of a curve are. So parametric equations, these are two equations. They are is x in terms of t and y in terms of t. From there, we'll be asked to find the gradient. Show that the gradient of the curve is always positive. So we have to find dy dx, that the gradient of the curve in this case first. Right, first thing, you differentiate. You find dx dt here. and define dy over dt in this case. But check the second part is you can use the quotient rule, u over v. Integration, a differentiation of u over v, it will be dy over dt in this case. It will be v du over dt, then plus, actually it's minus. Is there any formula booklet? Minus u, then dv over dt in this case over v squared. So this is how you differentiate this part. Then for the first part, it's just straightforward. It's differentiation of ln x, ln f of x. Ln f of x, you just say derivative over f of x. That's how you differentiate ln x or ln f of x, right? So it's derivative over f of x. So in this case, I can say dx over dt is derivative of what is inside the bracket, which is 2 plus 3t is 3 over 2 plus 3t, like this. Then for this one, I can say let u is equals to t and v is equals to 2 plus 3t. Then I can say du over dt equals to 1. Then dv over dt is equals to 3, like this. So my dy over dt is equals to v, which is 2 plus 3t, times du over dt, which is 1. Then minus u, which is t, times dv over dt, which is 3, over v squared. V squared is 2 plus 3t, then squared. Let me simplify this part. Remove the bracket, 2 plus 3t minus 3t over 2 plus 3t squared. Then if you can simplify it, you get 2 over 2 plus 3t squared. Because 3t minus 3t, that will give you 0. So it will be 2 over 2 plus 3t squared. Right, now to find dy dx, I have to use the chain rule. I have dx over dt and I have dy over dt. I want to find dy over dx. So to find dy over dx, I say dy over dx is equals to, then I can say dy over dt, then divided by dx over dt, such that dt will be the numerator. So I can find my dy dt in this case, which is this one, 2 over 2 plus 3t squared, divided by dx dt is this part, which is 3 over 2 plus 3t, like this. Then let's simplify this part to get my dy dx. So let's get dy dx here. It will be 2 over 2 plus 3t squared, then times 2 plus 3t over 3. While simplifying this part, this one, 2 plus 3t, one of it will cancel with this part. So we'll be left with 2 over 3, then 2 plus 3t. So this will be the solution for dy dx. Right, I found my dy dx. Then now come the part of showing that, the second part is saying, show that the gradient of the curve is always positive. How can you show that it's always positive, right? You check on this part. There is a logarithmic function here. X is ln 2 plus 3t. That's my x. Then for y, there's no problem. Was any value, you can get the value for y in this case. But for x now, there's no ln of a negative number. Ln of a negative, this one is undefined. You can't find the logarithm of that negative number. So it means the thing inside here must never be negative, right? So if it's supposed not to be negative, so what is it? It means that in this case, my t is not supposed to be the number that will give me a negative number. So they said here, show that the gradient of the curve is always positive, right? So it's supposed to always be positive, right? Because there's no ln of a negative number, which means inside here 2 plus 3t, it means t must not be equal to a number that will give me a negative value in this case, right? So in this case, since t cannot be a number that will give you negative ln, so in this case, it means what? If you can check up here, x is equals to ln 2 plus 3t. So what are the values of t? What are the values that t can take? So you can say e to the power x is 2 plus 3t, right? So t in this case must not be or give you a number that will give you ln of a negative number. So if you can check here, 2 plus 3t, if you can say the least possible number in this case is 0. Even ln of 0 is still undefined. Ln of 1 is 0, which means the least possible value that we can be able to get in this case is 1. So the least possible value that x can take is 0. You get it? So that the least possible value that x can take is supposed to be, this value is supposed to be 0. Because ln 0, ln 1 is 0. So in this case, x is supposed to be 0 in this case, right? So this gradient is supposed always to be positive. Why? Because t can never be negative in this case, right? So the gradient is always supposed to be positive. Right then, so the background is based on the fact that there is no ln or logarithms of a negative number. That's the effect. Right, find the equation of the tangent to the curve at the point where it intersects the y-axis. Equation of the tangent to the curve at the point where it intersects the y-axis. Y-axis, you can know that x is 0 and y is y. And this one is the tangent to the curve, which means gradient of the tangent and the curve, they must be the same. So gradient of the curve dy dx is equals to, is it 2 over 3? 2 over 3, then 3 plus 2 plus 3t. So this one is my gradient, 2 plus 3t. So gradient of the tangent and the curve, they are the same at the point where they meet. So where the point where this one crosses there is the tangent where where it crosses the y-axis. So x is equals 0. So to find the equation of the tangent of a line, tangent is a straight line. That's key. So if it's a straight line, then equation is y is equals to mx plus c. Like this. To find the equation of this type, we need two things: point and gradient. The point will help us to find the value of c, that is the y-intercept, right? Alright, so the gradient in this case, since it's a tangent and a curve, we can check here where it crosses the y-axis. So it means x is equal to 0. So if I can come up here, x must be equal to 0. And what is my x here? X is equals to ln 2 plus 3t. And what is my y here? And y will be equal to 0 actually. Y will be equal to 0. So if y is equal to 0, then I can use that one. Or let me first find the value of t. Then I can substitute where there is. So my y here is t over 2 plus 3t. 2 over 2 plus is t, not 2. Right, now we have to find the equation of the tangent to the curve at the point where it intersects the y-axis. That is when x equals to 0, right? So if you can put x0 in this case, you can find the value of t. So that you can be able to find the value of y here. Find the value of t, then substitute where there is y. You find the corresponding value of y, when x equals to 0. So put x0 first. It will be 0 is equals to ln, then 2 plus 3t. Then you can find the value of t. Then to remove ln, you put e. Raise e to the power 0 is e to the power ln, then 2 plus 3t, like this. E to the power 0 is 1. Then e to the power ln n number is called that number. So it's 2 plus 3t, like this. Then collect terms. In this case, it will be negative 3t is equals to t minus 2 minus 1. Then minus 3t is equals to 1. So you get here t is equals to, divided by minus 3 you get minus 1 over 3. That's your t, right? Now to find your y, you say y is equals to t, which is minus 1 over 3 over 2 plus 3t, which is 3 times minus 1 over 3. Now let me check. Yes, it's t over 2 plus 3t. That will be the corresponding value of y at the point where the tangent meets the curve. Right, simplifying this part, it will be minus 1/3 over 2, then minus 1. So 2 minus 1 is 1. So overall, you get minus 1 over 3. So the coordinate point, it will be x0, y minus 1 over 3. So this is the point where the tangent meets the curve. Now we have the gradient. Gradient, we put t is equals to the value that we have found here. So t is equals to negative 1/3. You can say dy over dx, that's my gradient, is 2 over 3 bracket 2, then plus 3 times negative 1/3. Like this. Then what you get, let me just write here for the sake of my space. So it will be 2 over, then 3, then 2 minus 1. Simplifying this part, 2 minus 1 is 1 times 3. So you get 2 over 3 as my gradient, right? So I can say y is equals to 2 over 3x plus c. Then I can use now this point I substitute to find the equation of my tangent. So where there is x, I put 0. Where there is y, I put negative 1/3. So it will be negative 1/3 is equals to 2 over 3, where there is x, you put 0 plus c. Right, let's find the value of c. 2 over 3 times 0. That one is 0 already. So I can get my c as negative 1/3. I can take this value, I substitute it here. Then that will be my equation. So it will be y is equals to 2 over 3x minus 1 over 3. So in this form, let's check the form. In which form? They didn't say the form that they require in this case. So you can just leave in the form y is equals to mx plus c. Then it will make sense. Right, then question number 7. Question number 7. The diagram shows the curve y is equals to arctan of x and its maximum point m, where x is equals to a. Then show that a satisfies the equation, this equation, right? In this case, you are supposed to find, they said m is the maximum point, which means dy dx at m must be equal to 0. What's dy dx at maximum point? Minimum point, turning point, stationary point must always be 0. So you have to differentiate this in this case. So dy dx, and this one you can use a quotient rule. You can say let u is equals to arctan x, and v is equals to root of x, and this is the same as x to the power half. Let me just put it as x to the power half. Then du over dx is equals to, right, arctan x. This one there in a formula booklet, right? Is there in your formula booklet. Let me find my formula booklet here. It will be my formula booklet. Right, but the differentiation of this part, it will be 1 over 1 plus x squared. One over 1 plus x squared. Let me check again. Right, so it's a is this one arctan on differentiation in this part. So differentiate arctan x, you get 1 over 1 plus x squared. So that's the item that you have to use here, 1 over 1 plus x squared, right? Then on this part, differentiate x to the power half, which is dv over dx. It will be equals to half x to the power half minus 1. So it will be half x to the power minus half. half x to the power minus half. Yes. So this one. Then based on the quotient rule is the formula booklet. You can check it on differentiation. It's a this is the one that you have to use in this case, right? So v du over dx minus u dv dx over v squared. That's the one that you have to use. So I can say here dy over dx is equals to v, which is x to the power half or root x, times du dx, which is 1 over 1 plus x squared, then minus u, which is arctan x, times dv dx, which is half x to the power root x, or x to the power minus half, then all over v squared. What is my v? It's x to the power half squared. So it's x to the power half or root of x squared. Like this. Right, then simplify this part. Then you have to equate your gradient to 0. Right, because maximum point m. So this will be root of x. Let me just put x to the power half here. Then over 1 plus x squared. Then minus. Then this will be half x to the power minus half. Then arctan x over this will be x. Let me just say this one is equal to 0. Then after that, you can just say simplify or cross multiply x and 0. X times 0 give you 0. So the item you will be left with x to the power half over 1 plus x the squared, then minus this minus 1 over 2 x to the power minus half arctan of x, then is equal to 0. Then you can check on your item. You have to show that a is equals to tan off, which means tan must go to the other side, right? So you have to make sure that you make arctan x subject of formulae in this case. So you can take whatever with arctan x to the right side of our equal sign. It will be x to the power half over 1 plus x squared, then is equals to half x to the power minus half, then arctan x. Right, then multiply by 2 and divide by x to the power minus half. So it will be multiply by 2, then divide by x to the power negative half, 1 plus x squared, like this. Then is arctan of x. Right, like this. Then after that, you can see x to the power half divided by x to the power minus half. These are laws of indices. You maintain the base and you subtract the powers. So it will be x to the power half minus half is x to the power 1. So it will be 2x over 1 plus x squared. Then it equals arctan of x. Like this. Then it will be, if you can get arctan to this side, it will be tan. So it will be tan 2x over 1 plus x squared, then is equals to x. Right, what do we have to show actually? Yeah, so that's it. So it's out. You can say, in this case, since they say x is equals to a the maximum point. So you can put a where there is x. So it will be tan 2a over 1 plus a squared. Then is equals to x. Then we can say shown. Or you can just write it as x is equals to, then tan, actually x is a. You can say a is equals to tan, then 2a over 1 plus a squared. Then this will be the solution. Done. Right, part B, that was part A. Part B, verify by calculation that A lies between 1.3 and 1.5. And what you do, you can say, take everything the left side of the equal sign. You can say A is equal A minus tan, then 2a over 1 plus a squared, like this. Then you can say let f of x equals this expression. Then after that, you can put f of 1.3 first and put f of 1.5. There must be a sign change. If there's a sign change, then you can deduce that there is a root between 1.3 and 1.5. It's more like the line, the curve must be crossing the x-axis so that there will be a solution for x here. Right, so that is so from negative to positive. So one negative, one positive, it means it's crossing this line. So there is a root for this of this function. Right, you can put 1.3, so it will be 1.3 minus tan 2 times 1.3 over 1 plus 1.3 squared. Like this. Then down here you can also say 1.5. So it's 1.5. Where there is a, you put 1.5 minus tan 2 times 1.5 over 1 plus 1.5 squared. Then you can simplify. Get your answer here. Make use of a calculator. So it's a, that's 1.3 minus, just punch in your calculator. Then it's tan, and make sure your calculator is in radian mode, right? Make sure your calculator is in radian mode. You change. So it will be 2, let me put over here, 2 times 1.5. Over 1 plus 1.5 squared. Close bracket, you get negative 0.0217 to 3 significant figures. Then for 1.5, if I can put 1 point, this one's 1.3. Oh, that's wrong because I've mixed 1.5 and 1.3 in this case. So let me put 1.5 first. 1.5 is 0.17883 or just 0.178 like this. Then for 1.3, let me put for 1.3 now. 1.3, so delete 3 up there, delete 3. Then outside supposed to be 3. 1.3, yeah, you get negative 0 point. Note this one, negative 0.148. So this one is negative and this one is positive. Therefore, there is a sign change between the two items, which means there is a root. So the conclusion, there is a sign change, so there is a root between 1.3 and 1.5. Then part C, use an iterative formula based on the equation in part A to determine A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Right, what is our equation? Equation is here. That's the equation. A is tan 2a over 1 plus a squared. A is equals to tan 2a over 1 plus a squared. Right, so what you do is, since we say there's a root between 1.3 and 1.5, is it 1.3 and 1.5? Yes. So you have to find your x0. Your starting point is what? You take the two values, you add them together, you divide by 2. You find the midpoint. I'm sure I must get 1.4 here. So it's 1.4. So here is x0 is 1.4. That's what you have to always do. Take the midpoint of the two values. Then x1 is equals to, so it will be tan. Then, so this one is a n plus 1, then a n. Right, so it will be tan, then 2 times 1.4 over 1 plus 1.4 squared. Then you get your item here. Let's punch in my calculator. So in the calculator, you just punch tan. Right, you just be pressing equal sign. So it's actually easy when it comes to iterations. Then it will be 1.4, just say times 1.4. Then over 1 plus 1.4 squared. I will get 1.3865. So give the result of each iteration to 4 decimal places. So these are 4 decimal places. Then I move on to x2. It will be turned. Where there is a now, I'm putting x0. Right? So this one is not x actually. Let me just use what is there. This one is a, not x, right? So I can use a in this case instead of x. So I say a0 here, then a1, then a2 here. And instead of x, use a. a2, let me put the proper one, a. So it's a0, a1, and a2. a2, you put a1. So it will be 2 times a1 here over 1 plus 1 plus. So a1, let me just put the value here. So it will be times 1.3865 over 1 plus 1.3865 squared. Then what we get here, press equal sign. So it's 1.3865. Looks like it's the item. Let me put it now. Right, so on your calculator, just put where there is 1.4, you can just put answer there. Answer. So just be pressing equal sign. Wait, it's 1.39, not this one. 1.3951. Then moving on to A3, it will be equals to turn. Then where there is a AN, you now put A2. So it will be 2 times 1.3951. So this answer that you got, this is the one that you have to put where there is A in this case. So plus 1.3951. Then you press equal sign. So it will be 1.3896. Yes, 96. Then your A4, what are they saying here? They said to determine A correct to 2 decimal places. So 2 decimal places now is 38, then 39, then 38. Let's check. So it will be 10, then 2 times 1.3896 over 1 plus 1.3896. Then what we get here? It will be 1.39311. As you can see, if we can round off this part, we get 1.39. This part, 1.39. So the root, which is A, is 1.39. If we can continue further, you get 1.3908. That's for A5, 1.3908, 7 something. So if you can still round off, you get 1.39. Then X6, then it's still the same, 1.392. So if you can round off, then you'll be getting 1.39. So that's the value of A, done. Next, question number 8. With respect to the origin O, the points A and B have position vectors given by OA is constant, OB is constant. The line L is the equation. Find the acute angle between the directions AB and L. AB and L. Right, direction AB and L. So you have AB, and you can have my line maybe L. A can be somewhere here, then B can be somewhere. So on the acute angle between AB and L. So to find the direction AB. Direction AB is equals to OB minus OA. So it's just this B minus A. What is my OB? Is 3, 1 minus 2. Minus OA is 1, 2, 1. Then if you can get simplify this part, you get 2 minus 1 minus 2 times then minus 3. So this one is the directional vector AB. Then directional vector of the line is this part, which is 1 minus 2, 1. Then 2, 3, 1 is called the position vector. That represents any point that lies on the line. Right, so I can say cos theta is equals to, actually I say the dot product of the directional vectors over the modulus of the directional vectors. So it will be AB, that is 2 minus 1 minus 3 dot directional vector of the line, which is 1 minus 2 1, over their magnitudes. Magnitude of is 2 squared plus minus 1 squared plus minus 3 squared, then times magnitude of the other item is 1 squared plus minus 2 squared, then plus 1 squared. Then I can just simplify. Cos theta is equals to, then on the dot product I say 2 times 1. 2 times 1 is 2, plus minus 1 times minus 2 is 2, plus minus 3 times minus 1 is minus, times 1 is minus 3, like this. So I will just have to multiply in this case. So it's 2 times 1 is 2. Let me check again. 1 times 2, yes, so it's 2, plus minus 2 times minus 1 is 2, plus 1 times minus 3 is minus 3. Then over, if I can simplify this part, 2 squared is 4. 4 plus 1 plus 9. 4 plus 1 plus 9, you get 14. Then dot square root of 1 plus 4 plus 1. 4, 6. So it will be cos theta is equals to, then 2 plus 2 is 4, minus is 1, over root 14. 14 by 6, what do you get? You get root of 84. Then you say theta is arc cos of 1 over root of 84, which is equals to, then arc cos of 1 over root of 84. So in radians, in this case, they said what? Find the acute angle between directions AB and AL. Right, so if it's in radians, then you are supposed to put 1.46 to three significant figures, or in degrees. If it's in degrees, then you are supposed to put 1 decimal place. So it will be 83.7 degrees. So whichever way, radians or degrees. So this the acute angle less than 90 degrees. Right, next, find the position vector of the point P on L such that AP is equal to BP. Find the position vector of the point P on L. Point P on L. Right, you have to sketch these items. Just you have to sketch the items. So if I can sketch this one, this is my line L. So P is supposed to be a point on L. In my L, you've seen the vector equation of line L. Then let me sketch first. Then AP is equal to BP. I can put my A here. I can put my B here. Let me put A here, that I can find my item for O. Then my B, I can put somewhere B here. So this one is AB, right? So I can put my A, then my B, then AP is this one. Then BP is this one. So AP is equal to BP, then I mark. So these ones must be the same. Then all these vectors, they are coming from a fixed point, which is called O. From the fixed point or from the origin, that is O. So this vector is coming from O. I can say OA, that's the one that I found. Then OP, I have to find my OP. Then I also have my OB. Right? So the position vector of B, that's OB. Position vector of A, that's OA. Position vector of P, that's OP. What is my OP in this case? Right, OP, I take the vector equation of the line. So it will be, I combine the two items. First thing, I say 2, 3, 1. Then plus, I multiply by lambda. Lambda times 1 is lambda. Lambda times minus 2 lambda. Lambda times 1 is lambda. Then I can combine these items so that it will be 2 plus lambda, then 3 minus 2 lambda, then 1 plus lambda, like this. So this represents the vector, the point or the position vector of any point that lies on the line. So it's 2 plus lambda, 2. I can say these are the points of P. 2 plus lambda. Then the next one is what? 3 minus 2 lambda, 3 minus 2 lambda, and 1 plus lambda. Right, so these are the points or the position vector of any point that lies on the line L in this case, right? Then OA is what? It's 1, 2, 1. Then OB 3, 1 minus 2, 1 to 1. Then this one OB is 3 minus 2, 1. Let me check OB. OB is 3 minus 3, 1 minus 2, 3, 1 minus 2, 3, 1 minus 2, 3, then 1, then minus 2. Eh, 3, 1 minus 2, that's OB, right? Then, right, I have to find the position vector of P, which means I have to find my lambda in this case. Then after finding lambda, I substitute. Then I can find the position vector of P, that's OP, right? But we're given that AP is equal to BP. So it means in this case, for me to be able to find my lambda, I have to find AP and BP. And these are the magnitudes. Please take note of that part. So if AP is equal to BP, that means the magnitude of AP is equal to the magnitude of BP. Take note of that part. Right. So magnitude of AP, what is my AP in this case? Right. I can find my AP. So AP is AO plus OP. This is the same as OP minus OA. Minus AO. OP minus AO. So what is my OP? OP is 2 plus lambda. Then 3 minus 2 lambda. Then 1 plus lambda. Minus OA. What is my OA here? My OA is 1, 2, 1. Then if I can simplify this part, it will be 2 plus lambda minus, it will be 1 plus lambda. Like this. Then 2 minus 2 lambda, then minus 2 on the other item. Then it will be 3 minus 2 is 1 minus 2 lambda. Then 1 plus lambda minus 1, it will be lambda. Like this. So this represents AP. Then next for BP, if you can check on our vector diagram, is BO plus OP. This is the same as OP minus OB. Because BO is negative OB. So it will be BO, then OP is the same thing, 2 plus lambda, then 3 minus 2 lambda, then 1 plus lambda, minus OB, that is 3, 1 minus 2. Like this. Then if you can simplify this, what you get is your BP, you get 2 plus, then it will be lambda minus 1. Then 2 minus 2 lambda minus 1, it will be 2 minus 2 lambda, that's 3 minus 2 lambda minus 1. Then 1 plus lambda minus 2, it will be 3 plus lambda. So this one is my BP. So if BP is equal to AP, then I can say the magnitude of AP is equal to the magnitude of BP. Since the lines, they are the same, they are equal. So they are equal in length, which means equal in magnitude. So AP here is this one. So it will be square root of, then AP is 1 plus lambda squared plus 1 minus 2 lambda squared plus lambda squared. Then must be the same as root of lambda minus 1 squared plus 2 minus 2 lambda squared, then plus 3 plus lambda squared, like this. So that's for the modulus, right? Square root of x squared plus y squared plus z squared. That's for the magnitude of vectors in 3 dimensions. So square root, they will just cancel out, right? You can just square both sides or cancel out. So we'll be left with whatever is inside there is under the square root. So 1 plus lambda squared plus 1 minus 2 lambda squared, then plus lambda squared, then is equals to lambda minus 1 squared, then plus 2 minus 2 lambda squared, then plus 3 plus lambda squared, like this. Then simplify for you to be able to get or to find your lambda in this case. Right, you expand. So this will be 1. Let me expand this side. It's 1. You can use shortcut. Okay, just say these are 1 plus lambda squared. It means 2 brackets of the same item. So 1 times 1, 1 plus 2 lambda, expand this bracket, then plus lambda squared. For the sake of space, then I can just use shortcut, but you can just expand this item. You can find the value. Right, then on this part, it's 1 minus 4 lambda plus 4 lambda squared. Then plus lambda squared. Then on this side, it's lambda squared minus 2 lambda plus 1. Then plus, then to be 4 here, minus 8 lambda plus 4 lambda squared. Then plus, this side will be 9 plus 6 lambda plus lambda squared. Yes. Now you have to collect like terms or just simplify. You can say the left side, the right side, there's lambda, there's whatever. So I can say lambda plus 4 lambda squared plus 4 lambda squared plus, it will be 6 lambda squared. 6 lambda squared on the left side. Then on the lambda side, 2 lambda minus 4 lambda. 2 lambda minus 4 lambda. Then what you get? You get minus 2 lambda. Then 1 plus 1 is 2. Is equals, on this side, lambda squared plus 4 lambda squared plus lambda squared is 6 lambda squared. Then minus 2 lambda minus 8 lambda plus 6 lambda. Minus 2 lambda is minus 10 lambda. Minus 10 lambda plus is minus 4 lambda. Then 1 plus 4 plus 9 is 14. Like this. Right, if you can check, then this 6 lambda and 6 lambda squared, they'll cancel out. So we'll be left with minus 2 lambda, then plus 4 lambda, collect like terms, is 14 minus 2. So it will be this part, minus 2 lambda, it will be 2 lambda. Then is equals to 12. Then divide by 2, you get your lambda is equals to 6. Like this. Right, then after finding your lambda, now we have to find the position vector of P. So P is here. We have found our lambda is 6. So if you can come up here, then you can now put P. So it will be 2 plus 6. Then 3 minus 2 times 6. Then 1 plus 6. Like this. Then what we get is the coordinates of P, 8. Then 3 times minus 12. 3 times minus 12 is the same as 12 minus 3. Actually, it's 9. Then 1 plus lambda, which is 1 plus 6, which is 7. So this will be your item, right? Then we can say these are the coordinates or the position vector of P. So it's 8 minus 9, 7. Right, question number 9. The equation of the curve is y is equals x to the power negative 2 over 3 ln x. The curve is one stationary point. Find the exact coordinates of the stationary point. Exact coordinate of the stationary point. Right, so what you do here in this case, we differentiate. At stationary point, you have to know that our dy dx gradient must be equal to 0. Right, so you differentiate, equal to 0, you can find the values of x. And then the values of y, both the exact, it means x and y. So this one is product. You can say let u is equal to this one and v is equal to this one. So you can say let u is equals to x, then minus 2 over 3, then u is equals to ln x, like this. Then you can differentiate du over dx. What is du over dx in this case? It will be negative 2 over 3. Then x to the power negative 2 over 3 minus 1. Then du over dx. That's ln f of x. So it will be 1 over x. So if you can differentiate, 1 over x, ln x, you get 1 over x, right? Please take note of that part. Then differentiate this part. What we get here, it will be simplify actually 2 over 3, then to be x to the power, right? Minus 2 over 3 minus 1. What is minus 2 over 3 minus 1? Right, you can find your calculator, punch in your calculator. You can find it's minus 4 over 3 actually. 2 over 3. 2 over 3. Then, so it's 5 over 3. It's 5 over 3. So it's negative 5 over 3. So you have to, please, you have to make sure that you check with your calculator, right? So that you avoid getting wrong answers. You avoid getting wrong answers. So check with your calculator always. In this case, it's not 4 over 3. It's 5 over 3 actually. Right, then you can simplify this part. It will be negative 5 over 3. Then this part, du over dx is equals to 1 over x. So we can now say, based on product, this one's product differentiation, it will be dy over dx is equals to, you can say v du over dx, then plus u dv over dx. Like this. Right, what is my v for my dy dx here? My v is this one is supposed to be my v. So v is equals to ln x. So dv over dx is uv. So my v is ln x times then du over dx, which is times minus 2 over 3, then x to the power minus 5 over 3, then plus u, which is x to the power minus 2 over 3, then times dv over dx, which is 1 over x, like this. Right, let's simplify this part. It will be minus 2 over 3. Then let me just start with this part. So it will be x to the power minus 5 over 3, then ln x. Then on this part, laws of indices, maintain the base and subtract the powers whenever dividing. So it will be plus x to the power minus 2 over 3 minus 1. Minus 2 over 3 minus 1. So suppose minus 5 over 3. It's the same as minus 2 over 3 minus 1. So it minus 5 over 3. Then I can say this one is equal to 0. Why? Because it's stationary point. Then from this, I can find the value of x in this case, right? So I will say, I can collect terms here. So I can say here, x to the power minus 5 over 3 equals to, then it will be 2 over 3. It's better to get rid or to run away from the negative values, right? So I can take this to the left side, right side of the equal sign. So it will be 2 over 3. It will become positive. Take note of that part. Then x to the power minus 5 over 3. Then ln x. Like this. As you can see, I can divide by x to the power minus 5 over 3 both sides, right? Or I was even going to factor out here. Even before, if instead of dividing, I can say here, let me just factor out. Because when it comes to letters, basically, and tricks, you don't divide, you factor out. So let's factor out x to the power minus 5 over 3. Then I'll be left with minus 2 over 3. Then ln x plus 1. Then is equals to 0. Then it's either x to the power minus 5 over 3 is equals to 0, or minus 2 over 3 ln x plus 1 is equals to 0, like this. Right, then from this one, you just get the solution x equal to 0 here. So if you can get x equal to 0, then if you can try to find y here, it will be ln 0. So it means that one, no solutions for that part, because ln 0 is an error. So it means this one, no solution. We can use this part now. So it will be 1 is equals to 2 over 3 ln x. Then it will be, you multiply by 3, you divide by 2. 3 over 2 is ln x. Then after that, you can put e. raised to the power e to the power 3 over 2 is equals to e to the power ln x. So our x is e to the power 3 over 2, like this. Then done. We have to find the corresponding value of y in this case, right? What did they say here? They said of the stationary point R, which means it's one. It's one stationary point. So these are the guiding items. So they will guide you. Because they said point, which means they are not two. It's just one point. So you can say x is equals that one, then y is equals to it's x to the power negative 2 over 3 ln x. So it's x to the power negative 3 over 2 ln x. Negative 2 over 3 ln x. So if x is called this one, then what is y? Right? What if x is called this one? Then what is y in this case? Let me check on this part also. Ln is ln x, then that's v, then d 2 over 3 x to the power. Okay, so that's correct. I was just checking on something. Right, so I can substitute now. Y is equals to x, which is e to the power 3 over 2, then times negative 2 over 3, then times ln e to the power 3 over 2. That will be y. Then simplify this, apply the laws of indices. It will be e to the power 3 over 2 times is actually negative 1. E to the power negative 1, then times, then e to the power, ln e to the power 3 over 2 is just 3 over 2. Like this. Then, next item, it will be e to the power negative 1 is actually 1 over e. So this will be the same as 3 over 2 e. Like this. So the solution, it means x is 3 e to the power 3 over 2. Then y is 3 over 2e. So these are the exact coordinates of the stationary point. Then we can say done. Right, next part B. These are 5 marks. These are serious marks. Hey. Then they said, show that. Then they said, the integral of y dx is equal to that one, where the upper limit is 8 and the lower limit is actually 1. Right. So our y here is up there. Our y here is up there. So it's y is equals to x to the power minus 2/3 then ln x. Please take note. This one, when you are on integration, you have to change it actually. So you have to say ln x then x to the power minus 2 over 3. Well, the first one, it will be u. Then the second one, it will be dv over dx. Then dx. So dv dx, if you can say dv dx is equals to ln x. It's equals to ln x. That's why you have to change. Then if you can separate variables, more like you are solving differential equation, ln x dx. So if you can integrate ln x, this one can't be integrated. So that's why you have to exchange the items, right? Because ln x can't be integrated. You can only differentiate ln x. So it will be ln x to the power minus 2 over 3. Ln x to the power minus 2 over 3, then dx. So it will be 8 and 1 in this case, right? Please take note of that part. So now what you have to do is to get rid of, or to apply our formula. Is there in a formula booklet the one for integration by parts, right? So this one is integration by parts actually. So what you have to do now is you have to say let u, because it's like this, the formula is like this: integral of u dv over dx is equals to uv minus the integral of v du over dx then dx. So our u, we have said let u is equals to ln x, and dv over dx is equals to x to the power minus 2 over 3, like this. Right, then this part, we can differentiate du over dx. What is du over dx? Is 1 over x. Then on this part, separate variables, x to the power minus 2 over 3, then dx. then integrate both sides for us to be able to find our v. So it will be integration now is 1 over minus 2 over 3 plus 1. Then x to the power minus 2 over 3 plus 1. You don't put plus a constant in this case. Right, then minus 2 over 3 plus 1 is 1/3. 1 divided by 1/3 is 3. X to the power, then this will be 1/3. So this will be your v. Right now, I have my u, my v, my du dx, then I have my dv dx, everything I have it now. So I can say this one, the solution will be uv, my u is ln x, then v is this one. So it will be 3x to the power 1/3, then ln x. So instead it just end with ln x, right? Then minus the integral of, then u, in this case, then v du dx. So my v is 3x to the power 1/3 times du dx is 1 over x, is this one, it's here. Then dx. Then simplifying further, it will be 3x to the power 3rd ln x. Then minus, then apply the laws of indices. I can say 3 here. Then x to the power 1/3 divided by x to the power 1. It will be x to the power minus 2 over 3. Then dx. Then I can integrate this part. Then maintain this part. 3x x to the power 1 over 3. Then ln x. Then minus. Then I can maintain my 3 here. Then times. Then on this part, I can say 1 over minus 2 over 3 plus 1. Then x to the power minus 2 over 3 plus 1. Then there are limits, so I didn't have to put constants. Their limit is 8 and 1. Why? So the limits, lower limit is 1, upper limit is 8. So 8 and 1, like this. Right, after that, I have to simplify this part. So it will be 3x to the power 1 over 3 ln x. Then minus, right, minus 2/3 plus 1 is 1/3. 1/3 times 3 is 9. X to the power, then 3 divided by 1/3, it will be 9. Then minus 2/3 plus 1 is 1/3. Then it will be 8 and 1, like this. Yes, now I can put 8, then subtract and put 1. It will be 3 here. Then where there is x, I put 8. So it will be 8 to the power 1 over 3. Then ln 8 minus 9. Then 8 to the power 1 over 3. Minus, then I can put 1 is 3. Then 1 to the power 1 over 3. Ln 1. Ln 1 is 0. Then minus 9. Then 1 to the power 1 over 3. Like this. Then, so this part will be reduced to 0. And this part reduced to 9. So this side, it will just be plus 9. Let me just say plus 9 on this side. Right. Then on this side, it will be 8 to the power 1/3 is 2. 8 to the power 1/3 is 2. 2 times 3 is 6. So it's 6 ln 8. Then minus. Then 8 to the power 1/3 is 2. 2 times 9 is 18 plus 9. Right, so it will be 6 ln 8, then minus 9. So this will be your answer. Let's check the requirement of the question. They said show that. So it's supposed to show. We've already shown. So that's, but it's supposed to be 2. It's supposed to be 18 ln 2. So there's supposed to be 2 here. But negative 9 is already there. So it's supposed to be ln 2, not 8. So how do you show? It says 6. You apply the laws of logarithms. So this one's ln 2 to the power 3. Right? That's 8 minus 9. So this will be applying the laws of logarithms is 6 times 3. You bring down the power. Ln 2 minus 9. 6 times 3 is 18. So it will be 18 ln 2 minus 9. Shown. Done. Right. Next question. Number 10. These are differential equations. The variable x and t satisfy the differential equation, that one, and x equals to 1 when t equals 0. Then they said, using partial fractions, solve the differential equation, obtaining an expression for t in terms of x. These are 11 marks. It's a serious one, but simple, easy. Alright, so what you do is, they said using partial fractions. They haven't. They're not supposed even to tell you this one. Now it's easy. Why? Because they are telling you to partialize first. So it's partialize that item first. Right? How do you partialize? First thing on differential equations, you separate variables. So it will be dx over then x squared 1 plus 2x is equals to then dt, like this. So you're supposed to integrate both sides like this. But this side, there is 1 over x squared. Actually, let me write it here. 1 over x squared 1 plus 2x. So this item is the one that you have to express in partial fractions first. So you say there is a quadratic factor here. So if it's quadratic factor, you say ax plus b over the quadratic factor, then plus c over the linear factor, which is 1 over 1 plus 2x. Then you can multiply everything by this one, x squared 1 plus 2x. So it's to get rid of the denominators. So it will be 1 is equals to, then this side it will be ax plus b, then times 1 plus 2x. That's what will be left on this side. Then plus c, then on this side it will be x squared. Like this. Right, we have to find the values of a, b, and c. So we have to use elimination method in this case, what I can use. So I can say when x goes to 0, I can eliminate a and c. When x is equal to 0, then it will be 1 is equals to a 0 plus b. Then this side 1 plus 2 times 0. Then plus c times 0 squared. So it will be 1 is equals to, then a will be reduced to 0. Then on this part also, so it will be b times 1b. Like this. So b is equals to 1. Right? I can eliminate one more letter or two more letters. Then I can say when x is equals to, let me check. Right? If I can eliminate a and b, I can take my x to be negative half. So when x is equals to negative half, so that it will be 0 on a and b. So it will be 1 is equals to a times negative half plus b, then 1 plus 2 times negative half minus half, then is equal plus c times minus half squared. So this one will be simplified to 2 minus 1 0. So it will be 1 is equals to, then negative half squared is 1 quarter. 1 quarter c. So from this you can get 4 is equals to c. So c is equals to 4. Now I am left to find a. Right, for a, I can choose any number that I want. So I can choose when x is equals to, I can choose 1. 1 in this case, right? Then I can put 1 in this item. That's what I'm using. So it will be 1 is equals to, then a times 1 plus b, then 1 plus 2 times 1, then plus c times 1 squared. Right, I'll just substitute the values of a and c, of b and c that I found. So the 1 is equals, then this one will be a plus b, then times this part 2 times 1, 2 plus 1, 3, then plus c, like this. So the 1 is equals to, if I can simplify, 3a, actually I can just see 3a, let me remove the bracket, plus 3b plus c. I want a in this case, so I can say 1 is equals, where there is where there is b and c, I can replace b is 1, c is 4, plus 4, like this, so that I can find my a. 1 is equals to, then this will be 3a plus 3 times 1, 3 plus 4 is 7. Then I can take this side, so it will be 1 minus 7 is equal to 3a. 1 minus 7 is minus 6 is equal to 3a. Then if I can divide by 3, I can get a is equals minus 2. Negative 2. How much space do I have? Oh, there is more space. Wow, it sounds so fine. Then I can now say that one on that side, let me put it here, is ax. Ax plus b then plus c. So I can say now, I can use where there's a, I put minus 2. Where there's b, I put the value of b, which is 1. So it's minus 2x plus 1 over x squared. Minus 2x plus 1 over x squared. Then plus my c. Let me check my c here. C is equals to 4. So it's 4 over 1 plus 2x. 4 over 1 plus 2x. Then I integrate this side. Then dx is equals to. Then on this side, it was just the. Is this dt? Yes, it's just dt on this side. Yes, correct. Right. So I have expressed in partial fractions, which means this part must be clear. You have to put it right away here, or just without integral signs. What they said by first expressing in partial fractions. Right. Then next. So these are now partial fractions. Right, on this part, I can use integration by inspection, or I can just use the derivative item. Still it will work. Right. So check, the numerator is minus 2x plus 1, or I can just put numerator up there. Still it will work. So I can again just say by inspection it will not work, but by taking this one x squared up there, so it's minus 2x plus 1. Then let me take x squared. It will be x to the power minus 2. First, let me simplify this part. Over 4. Then this part, I will maintain it down there. 2x dx. Then is equals to integral of dt. Then this part, remove the bracket. What do you get? You get minus 2. Then it will be x times x to the power minus 2. Maintain the base, you add the powers. So it will be x to the power minus 1. Actually, x to the power minus 1, it will be 1 over x. Let me just. Then plus x to the power minus 2. Then plus 4 over 1 plus 2x dx. Then is equals to dt. Then integral. Then let me simplify this further. It's minus 2 over x. Because x to the power minus 1. That one you can't integrate. You can't. So you have to put it down. So it's to apply the logarithms. Plus x to the power minus 2. So this one minus 2 can be integrated. Then plus 4 over 1 plus 2x dx. Then is equals to integral of dt. Like this. Right. So on this part, I can say minus 2 integrate 1 over f of x. You get ln x. Right. Then plus, in this case, it will be minus integrate x to the power minus 2. X to the power minus 2, it will be 1 over minus 2 plus 1. Then x to the power minus 2 plus 1. So it will be minus x to the power minus 1. Like this. Then plus, this will be 4 over 2. Then ln 1 plus 2x. Then is equals to integrate dt, you get t plus a constant. Like this. Right, then, right, so integration of 1 over f of x. Integration of 1 over f of x. This one, you say ln 1 over derivative. Then times ln f of x. That's how I integrate ln f of x. Right, so please take note of that part. Take note of that part. Right, then. Right, then what we're supposed to do now is right, so this part. The other part will be finished because my battery is a bit low now. It can switch off. Right. So this part, what you have to do now, you just have to simplify. So combine this with ln minus 2 ln x. Then minus 1 over x. Then plus 2 ln 1 plus 2x. Then it equals to t plus a constant k. Right. Then what you have to do now is find the value of the constant k. How do you find k? Right. To work out k, you come up here. You put x1, and t is equals to 0, then find the value of k. After that, you can be able to replace k, then express y in, you can express now t in terms of x. Please like, share to this video. It's a nice one. I'm sure you can agree with me. Thank you.